9.2, we're going to actually start testing with population proportions. We've learned all about significant testing in general and type 1 and type 2 error, but now we're actually going to get to calculate and make decisions. So the objectives are to check the conditions for carrying out a test about the population of proportion, which we'll notice the checking of the conditions are the same from confidence intervals. Conduct an actual significance test about the population proportion, so this is going to be like your do step. And then we're going to construct a confidence interval to draw a conclusion about for a two-sided test of a population proportion. So we're going to make the relationship between a two-sided test and confidence interval here. So remember from 9.1 we talked about this idea of a p-value and significance test, meaning that the p-value is the probability that we reject probability that we get the value we got from a sample or something more extreme. And we'll learn how to do one-sided and two-sided tests. All right, so if we recall our basketball player who claimed to be 80% free throw shooter. In a simple random sample of 50 free throws, he made 32 of them. His sample proportion he made was 32 out of 50, which is 0.64. Is much lower than what he claimed. Does it provide convincing evidence against the claim? So this is the idea. Is this low enough to prove that he's not 80%? That's the question that we're asking. And so in order to do that, we actually can do a significance test. So we perform the significance test. You've already learned how to write the null and the alternative here. That he says that he's 80%, so P is equal to 0.8. Remember, it has to be a P because it's dealing with the population proportion. And then the alternative is that, no, it's less than 80. And they remind you that P is the actual proportion of free throw shoots he makes in the long run. So we have to check our conditions. And I told you that our conditions were going to be the same as they were for confidence intervals. So they remind you in Chapter 8, we introduce 3 conditions that should be met before we construct a confidence interval for an unknown proportion. They have to be random, normal, and independent. And these same conditions must be verified before carrying out a significance test. So what's nice is that we're not learning anything new here. You've already done this, you're used to doing it. You still do it in the plan step just like you've been doing it, and nothing's really changed there. So remember, random, we can view as 50 shots as a simple random sample from the population. Normal, okay, remember when we're dealing with proportions, we're going back to this n times p has to be greater than or equal to 10, okay, which they are, so the normal condition is met. This is really important. Remember, the n times p and n times q for normal goes with proportion, and that's that notes I gave you where you did the hot dog and the hamburger, style notes. Independent, our simulation, this is a simulation, so the outcome of each shot is not determined by, or is determined by a random number generator. So individual observations are independent. All right. So here we go. We have the null hypothesis is true. Then the player's proportion of made free throws of a simple random sample of 50 would vary accordingly to approximately normal distribution with a mean. So they're saying that if it's true, we're going to have a normal distribution, which means the mean of my distribution should be 0.8, which is what we hypothesized it to be. And we can find what the standard deviation should be by using this formula right here. Remember that this formula is right off of your green sheet. And notice that they use here, they've used the proportion from the null to go in here. Notice they used 0.8 and 0.2. They did not use sample proportions. They used the proportions from the null or from the actual population, what we think it to be. And then here's our standard deviation. So now we have a mean and a standard deviation here. So if we have our mean and our standard deviation, here we go. So here's our mean and our standard deviation with our curve drawn, and then we show that the p hat, what he actually got, or what we got from our sample, falls right here. And so what we want to know is how likely is this to have happened? How likely could this just have happened by chance? Because this is where he says it should be with what a standard deviation should be with the null being true. We would get this. So this area down here, like past this point, I just shaded in, is actually going to be called your p-value. remember, because the p-value is the probability of getting the result we got from our sample or something more extreme, given the null is true. So this is assuming that the null is true. Remember, this standard deviation came from the true null, or what we assume that it to be true. All right, so the calculation, test statistic, and p-value. A significance test uses sample data to measure the strength of the evidence. Okay, the test compares the statistic calculated from a sample data and the value of the perimeter of the null hypothesis. Perimeter. Values of the statistic far from the null. So like the further my actual sample statistic is from the null, remember here's the null right here, okay, in the direction specified by the alternative, so below 80, right, because we wanted things, the greater the evidence we have against it. So the further my value lies on this normal curve, this p-hat from the null, the greater the evidence we have. So here's the test statistic. You take your statistic, right? So we all know the statistic comes from the sample. Okay, so really, you know, you're taking the sample value minus the population value, right? And this population value comes from the null, okay, so you can put H naught, that's what that is, it's the null, right, over the standard deviation of the statistic, okay, so, and we're going to get into what the standard deviation of the statistic is.